Oh, hey. Good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. The date for today is January 24, 2025, and this time is 21:11. 21, that's minus 12, it's 9:11 p.m. January 24. My topic for this evening will be a long video format topic, and this is a continuation of my DC circuit long video format topic. Okay, let's proceed. The lesson for tonight will be a continuation of my long video format DC circuit. So this should be DC circuit lesson number 25. This is lesson number 25. And the title of the topic is Y to Delta conversion. Y to Delta conversion, or Y sometimes we call it star, but since the figure is something like a letter Y, we prefer the Y to Delta conversion. Okay. This is a Y connected loads. This is a Delta connected loads. So what we will be discussing tonight is to convert if we are given a Y, and what will be the equivalent of this one in terms of a Delta connection. Okay. Oh, a preview to this before we will discuss the so-called Y to Delta conversion. We are given this circuit here. This is just an illustration to explain why we need to convert Y to Delta. It is something like this. Hold on. I will try to get a piece of paper. If we are given this circuit here, if the resistances inside are missing, this is RA, RB, and RC. Supposing it's not inside. Okay? So the circuit will be a simple one. Okay? But if we try to insert the three resistances RA, RB, and RC with this connection, if we try to simplify the circuit, supposing the circuit is asking for the total resistance, RT equal to this one. If we are given this configuration, without RA, RB, and RC, the solution will be a simple one, right? But if RA, RB, and RC is inserted with this given configuration, if we try to compute for the total resistance of the entire circuit, it will be a complicated one. Okay? And to make the solution simpler, we will be converting this Y portion here to its equivalent in terms of delta, such that the resulting circuit will be much simpler to evaluate. Okay? Like this one here. If we try to simplify this one, I will start here. If I will try to disconnect this one, okay? If I will try to disconnect, the series combination of RB and RC is actually in parallel with R sub 7, right? But the problem is, RA is connected at the middle. This is connected. So we could not say that the combination of RB plus RC is in parallel with this. So we could not use the theory of the so-called parallel simplification. We could not do that, right? So to simplify the calculation, we must have to convert this RA, RB, and RC, okay, to its equivalent in terms of delta. There will be a resulting resistance here, right? There will be a resulting resistance here, and there will be a resulting resistance here. Then we could try to remove RA, RB, and RC now, because we got the delta equivalent. So the key to the solution of this one is that for the solution to be simpler, we must have to convert this y here to its equivalent in terms of delta, such that after the conversion from y to delta, this is gone, this is gone, this is gone, and this one will be connected here, this one will be connected here, this one will be connected here, and this one will be connected here. So after the conversion, the resistances RA, RB, and RC is gone, right? So it seems we eliminated this portion already here. Okay, so after the conversion, we could now say that this RB here is in parallel with this. And this is not that way. This resistance here will be in parallel with this. This one is in parallel with this, and this one is in parallel with this. So we could use the simplification by using the parallel Choray combination. So before we could do that, we must have to convert that RA, RB, and RC to its equivalent in terms of delta. So this will now become R1. Sorry for that one. This will now be R1. Okay, this will be R2. And this will be R3. We could compute for R1, R2, and R3 with the given values RA, RB, or RA, RB, and RC. So the key to the solution of this one is the conversion from Y to delta. Okay, you got it, guys? Okay, I will try to bring out this RA, RB, and RC. It will be this, right? So this is actually terminal X. This is terminal X. This is terminal Y. And this is terminal Z. Okay? So it seems the one we are looking for, there will be an R1 over here. Right? There will be an R2 over here. And there will be an R sub 3 over here. This should be R1 now. Sorry for that one. This will be R1, this is R2, and this is R3. We will try to eliminate this RA, RB, and RC, and what will come out will be the delta equivalent, which is R1, R2, and R3. This will be the configuration now. Like what I said, after the conversion from Y to delta, R1 now will be in parallel with RC, R sub 3 will be parallel with R sub 7, and R sub 2 will be parallel with R8. So we could proceed with the solution from right to left. So without the conversion from Y to delta, we could not solve the problem. So the importance of this Y to delta conversion is that if there is a delta connection or if there is a Y connection, in which it will make the circuit complicated, we must have to convert that Y to delta for it to become simpler. Okay? So the title of the topic for tonight, I will try to check my camera. It's fine. Right? This one is actually over here. I bring it out. And the delta equivalent will be this one. This is RA originally, RB, RC. So the equivalent of this in terms of delta will be R1, R2, and R3. And for the resistance specification, because these are loads, these are resistance loads, right? RA, RB, and RC are actually the Y loads, which make the simplification of the circuit hard if we try to stick with the Y connection. Because without converting this Y connection to delta, we could not solve the problem. So it's a must that we should convert from Y to delta. So in here, the specification RA, RB, and RC are actually the Y loads, and these are the given ones. These are the loads which make the simplification of the resistances difficult. Okay? And the resulting equivalent delta load will be R1, R2, and R3, and these are the equivalent delta loads. So it seems what is given here, we will try to convert it, so the resulting circuit will be a simple one. Okay, let's try to bring out the conversion equation. This is a mass for the conversion from Y to delta. An equation, H delta load, okay, is equal to the product of adjacent Y divided by, this is all over, the summation of R of Y. The meaning of this, if we try to convert for R1, R1 is actually the delta resistance equivalent. If we try to compute for R1, it will be the product of the adjacent resistances considering R1. The adjacent resistances considering R1 is actually RA and RB. Okay, so I place it here. R1 will be the product RA, RB all over the summation of the resistances in Y. And this is a sigma notation, right? The summation of the resistances which are connected in Y. So summation of R with the subscript Y, meaning it will be the sum of RA plus RB plus RC. So this denominator here is actually this one. As simple as that one. If we try to compute for R1, I will repeat it. It will be RA, RC divided by the summation of RA, RB plus RC. If we try to compute for R sub 2, the adjacent resistances connected with respect to R2 will be RA and RC. So R2 here is RA times RC all over the summation of the resistances in Y. And if we try to compute for R sub 3, it will be the product of the adjacent resistances considering R3, and the adjacent resistances considering R3 will be R sub B. This is R sub B. RB, RC, all over the summation. So this is RB, RC, all over the summation of the resistances of those connected in Y. So to use the Y to delta conversion, we must have to use this one here, this one, and this one. So I place it here memorized. Because these are the formulas on how to compute for the equivalent delta loads if we are given a Y connected load. It will just be simply the product of adjacent all over the summation. Considering R1, I will repeat it, R1 will be product RA, RB over the summation. R2, it will be the product RA, RC, okay? Because these are the resistances adjacent to R sub 2, okay? All over the summation. And R sub 3 will be the product RB, RC all over the summation. It is this. Okay, that's it, guys. Y to delta conversion, we needed this one and the so-called computation of the total resistances of the circuit. If the given configuration consisted of a Y connected resistances, and which will make the computation of the R total very hard to solve, we must have to convert that Y to delta for the given circuit to be solved easily. Okay, that's it, guys. So the importance of this Y to delta conversion is that it is in the computation of the R total. Because if we are given a complicated circuit which might consist a Y resistance and which will make the circuit very hard to solve, we must have to convert that Y to its equivalent of delta for the resulting circuit to be much simpler. Like this one here. Upon the conversion of RA, RB, and RC to its equivalent in terms of R1, R2, and R3, this will now be in parallel. Okay? R3 and R7 will now be in parallel. Okay? R2 and R8 will now be in parallel. So if we try to simplify this one, the total of this plus this will now be in series, right? So we could do that. And the single equivalent of this one here will now be in parallel with R2. So we could now take the single equivalent of this one. Right? And this single equivalent will now be in series with R sub 5. Okay? And the single equivalent R sub 5 and the single equivalent of this one here will go here. The single equivalent of this one will now be in parallel with R sub 9. Right? And the single equivalent of this one now will now be in series with R sub 4. So R total now will be equal to R sub 4 plus the single equivalent of all of this one. But without knowing the conversion from Y to delta, okay, this is very hard to solve, right? So the key to the solution of the total resistance is that we must have to convert that given Y to delta for the resulting circuit to become simple. Okay, that's it, guys. So for those of you who would like to subscribe or watch my channel is at youtube.com/@ProfDavidJ.De Los Reyes. If you want to share it, please click share. For those of you who would like to watch my channel on my long video format topics, my long video format topics are differential calculus. It's a complete course already. Integral calculus, differential equation, advanced math, DC circuit, I got AC circuit, algebra, trigonometry, and analytic geometry. Those are my long video topics. If you would like to study those different mathematics, you could watch my channel. Under my short videos, it's a combination of electronics and some other things. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes.